Let's now compute the quality baseline for our model. Remember, in the last session, we did the same thing, but for the data. So we generated the baseline that we will later use to monitor our model, not the performance of the model, but the data that comes into our model. We want to be able to raise any violations, detect any drift on that data. In this session, we are going to generate the baseline that we can use to monitor the quality of the model predictions. Now, very simple. If you were to think about how to do this, you will know that in order for us to know whether there is drift in the model predictions, we need to understand what those model predictions look like, right? So we need to have, let's say, a baseline accuracy that we should compare our model against. How do we compute that baseline accuracy? Well, the best way is to use the test data that we generated in the pre-processing step. If we use the test data to determine what the baseline accuracy is, we can then monitor the quality of the predictions later and compare them against the baseline accuracy on the test data. That is what's going to happen today. Here is the little diagram, and then I'm going to show you the AWS architecture diagram. But the diagram here is we're going to start with the pre-processing step. We're going to grab the train data to train a model. We're also going to grab the test data and send it to this generate test predictions. There are two steps here. This is a little bit more complex than the base quality, the baseline quality for the data, because here we need first to generate test predictions. We need to take that test data through the model, generate all of those test predictions, and then use those predictions to compute the quality baseline. That's what you see here. We're going to be using the model that we train and the test data to generate the test predictions. And then we're going to use those test predictions to generate the model quality baseline. Let's look at the diagram here. As a reminder, this is what we had to do. These three steps here, or these three components here, were the ones involved in generating the data quality baseline. For the model monitoring portion, we're going to need to use the test set that we generated in the first step, and we're going to use the pipeline model that comes from our training data. We're going to use those two, and we're going to take them through a batch transform job. And this is the first time you're going to see a batch transform job. So I'm going to explain how that works in a second. That batch transform job is just going to generate predictions that we're going to store in S3. And then the quality check step is going to use those predictions to generate the baseline metrics. This is the portion that we are going to cover right now, like the portion of this diagram. We need to generate the test predictions, and we're going to use those test predictions to generate the baseline quality data. Now, how do we generate those test predictions? Well, we are going to be using a batch transform job. So let's go to the code really quick and let's try to cover all of that. The first step is to just generate the location where I'm going to be saving the model quality baseline. This is just an S3 location. Then I'm going to be creating a model. So here is the explanation for the batch transform job. By the way, if you go to SageMaker, there is within training, maybe? No, it's within inference. Sorry, it took me a second there to find it. When you go to inference, the same location where the endpoints are, you will find the batch transform jobs there. You're going to give that batch transform job data, an explanation how to process that data, and a model, and SageMaker will get that data and will take it through the model in batches. That's pretty much how it works. The good news about a batch transform job is that SageMaker will optimize the process of doing that. Like basically, if I have 10,000 rows that I want to generate predictions for, I do not need to run them sequentially. SageMaker will be smart about that and basically will generate multiple instances of the model and will take all of those samples, all 10,000 samples, through the model in an optimized way to make this fast. That is what a batch transform job is. We're going to have to configure a batch transform job to get our test data through the model that we created. In order to do that, SageMaker is going to ask us for a model. So we need to have a model pointing to the model assets that we created before. Remember that a model is going to be here. So it's one of these models that lives here, this instance that we had to create in order to create an endpoint. We do not need an endpoint. Like the batch transform job does not require a live running endpoint. It only requires an instance of a model. SageMaker will take care of hosting that model internally, behind the scenes, running it so it can actually create predictions. First step here is just to create that model, and this is very simple. As you can see, I'm just saying, hey, just create a model step. It's the same step that I used to register the model, but instead of calling register, I'm gonna be calling create. Again, same step that we're gonna be adding to the pipeline, but instead of calling register, I'm calling create. I'm just calling that function create. I'm using the pipeline model that we defined before, calling the create function and specifying the type of instance that I'm gonna be hosting this model in, and SageMaker will take care of the rest. So this is my simple step. You're gonna see how the batch transform is gonna point back to this create model step. Now let's set up that transform step. The transform step is the SageMaker out-of-the-box step that we can include in our pipeline that behind the scenes uses a batch transform job. In order to create the step, just like when we were creating a processing step, we needed to create a processor. Well, in a transform job or a transform step, we need to create a transformer. It's going to specify sort of like the configuration for this job. In our transformer, I need to specify the name of the model, and I'm going to be using the create model step that we're going to be adding to this pipeline, properties.model name. So whatever the model name is, that's what I'm going to be pointing this transformer to. The type of instance that I'm going to be using to run this batch transform job, how many of these instances? I'm going to be using one. And now this is sort of like the configuration of that transform job or part of the configuration. The strategy is going to be multi-record. And if we go here to the transformer instance, I have the documentation right here. If I could click on it, you're gonna see, like, for example, the strategy is the strategy used to decide how to batch records in a single request. I'm personally using multi-record because my pipeline jobs support batches. I don't need to just grab line by line and send it to the model. I can grab multiple records at once and send them to the model in batches. That's why I'm specifying multi-record here. Where is it? Okay, strategy multi-record. I'm gonna be doing that using text CSV. I'm gonna be accepting text CSV back. I'm gonna be assembling this with line. Let's go to assemble with, and it says how the output is assembled. Default known, valid values are line or known. I want to assemble the output in a line. The output path, where am I gonna be saving the results of the batch transform job? Well, they're gonna go to this location, S3 location transform, which I'm gonna show you what's inside so you see the output of the batch transform job. And what is the session that I'm gonna be using? This is the transformer configuration. Let's configure now the step, which is gonna take a little bit more, but not much. This is the transform step. This transform step is gonna use the name generate test predictions. I'm gonna be using the transformer that I just created. I'm calling the transform function, and this is the config of that transform function. First, what is the data? What data do I want to use to do this transformation job or this batch transform job? Well, I'm gonna be using the test baseline. Remember that I generated train baseline and test baseline during the pre-processing step in this pipeline. The reason I'm using this baseline and not the original test set is because this baseline is before I transform that data. Same thing that happened with the train data when we were generating the quality check step. We want the data to be raw. We want that test data to be raw. So this is my test baseline. That is the data that I'm gonna be using. Then I specify the join source. Basically what I want to happen is I want the output of this transform step to include both the input data and the prediction. I could configure this so it only returns the prediction, the output of the taking one sample through the model. But I actually want to join that with the input so I have the entire record. I have the input that was sent to the model and the output that came out of the model. So that's what I'm doing right here. The split type is how the transform job is going to split the data. I'm going to be using line, and the content type is text CSV. All that I'm going to do here is just going to be using CSV. I'm not going to use JSON for this portion of the problem. So that's what I specify there. Then it says, what is the output filter? Like, how am I going to output or filter the output? I get the input and I'm putting the input next to the output. So I'm going to filter that down, and I want to get the first column and the 2 columns from the last one as the output. So this is what's going to happen. By joining the input with the output, we're gonna get something that looks like this. I have an example here so it's clear. I'm gonna get an input that's gonna look like this. Gen2 in this case is the species column, so that will be my ground truth, plus the Coleman length, Coleman depth, flipper length, body mass, sex. That is the input that I'm gonna be using to send to the model. The model is then going to make a prediction and put back an output. And I'm using the join source with input here, so the output of the transform job contains both the input and the output together in one line. So then it will look like this. Gen2, which is the predicted class, 0.52, which is the confidence. This is the data that we're gonna have ready before we do the final filtering. And that final filtering specified here. And notice that I want to keep column 0, which is the ground truth, Gen2, and column -2, which is 1, -1, -2, which is the prediction. The output of this transform job should be 2 columns, one with the ground truth and one with the prediction. That is what I want to get out of my transform job. Let's go to the transform folder in S3 so you can see the data that I generated after running this. So I'm gonna go up a couple levels. Should have a transform. Here it is, transform, and this is the out file or the the output file. I'm gonna go and open that output file. There you go. I'm gonna open this. Actually, I'm gonna have to bring it here. There we go. This is what I'm gonna be getting. This is the output of running my model through my test data. And by the way, this is only 50 columns here, and I don't think there are any mistakes here. I'm just trying to identify any mistakes. No, there are no mistakes here. So that means that in this particular case, my pipeline will report that the accuracy is 100% because there were no mistakes here, which is great. That's awesome. Okay, cool. So this is my transform step. I'm gonna have to add that step to the pipeline. Before I do that though, I need to configure my quality check step, just like we did in the previous session. Now we have the source data that the quality check step is going to be using. Notice something interesting here, and that is I'm gonna be using exactly the same step. So the quality check step in SageMaker works for both data quality baselines and model quality baselines. And depending on the configuration is how it's going to act. So I'm gonna still be using the quality check step. We already talked about this section here in the previous section. This configures the job that is gonna be running. I'm specifying an instance type, how many instances, the volume size in gigabytes, and a session and a role. This is just the same thing that we already saw. The name of this step is going to be generate model quality baseline. The other one we named generate data quality baseline. This is gonna be generate model quality baseline. Now look at this, the quality check config now is going to be model quality check config, which is different than the one before, which was data quality check config. For the model quality check config, number one, what is the baseline data that I'm going to use? Well, I'm going to use this file. This is the baseline data. This is what the input to that quality check step is going to be. Very simple file to understand. So I'm going to be pointing the baseline data to the output of the transform job, because that transform job is going to generate this output. I want this to be the data for my quality check step. The dataset format is just a CSV file. This is a CSV file, and there is no header here. So that's what the one that I'm going to be using. What is the type of problem that I want to generate baselines for? Well, it's just a multi-class classification. That is the type of problem that I need to create. What is the ground truth attribute? And here, because I'm using CSV and there are no headers, well, by default, SageMaker will create custom column names. So there is a specific format that you can see in the documentation of how they named each column. Column 0 will become this one, and column 1 will become the prediction. So that's what I'm specifying here. Well, the ground truth will be underscore column 0. That again, that's the name by default that SageMaker is gonna give my columns. And the inference or the prediction that I generated is going to be column one, which is this one here. I'm telling SageMaker how to interpret my data here. Finally, I'm gonna save the outputs in the S3 location that I specified before. What is the model package group name where I'm gonna be storing all of this drift information and quality information? This is the model package group, and the skip, check, and register new baseline properties work exactly like we discussed them in the previous session. That's it. That is my quality check step. It's ready to go. We just need to do model metrics, registration condition, done. So let's see that. For the model metrics, I'm going to do exactly what I did in the previous one. The quality check step for my model will generate a ton of information. Will generate model statistics, will generate recall precision, will generate accuracy. I can use all of that information and report those in my model registry. That is what is going to happen right here, where I'm gonna create model quality model metrics, and I'm going to get all of the information out of my quality check steps, and I'm gonna fill these model metrics with that information. Same thing for the drift check baselines. We talked in the previous session what the drift check baseline is for. After configuring my model metrics, let's register my model. I need to change that. So my new model is going to be registered in the pipeline package group with the new model metrics, with the new drift check baselines. Remember that this model supports both text CSV and application JSON. Awesome. And then finally, the condition step. The condition step now is different. Why? Because I need to add the new steps that I created. So if the model is successful, if after we train the model, the evaluation step says, yeah, the accuracy is good, the condition is going to first call the create model step, then it's going to generate the test predictions, then it's going to generate the baseline quality check step. These are the three new steps that we just created. And finally, I'm going to register the model after all these three things happen. So I'm only going to get here if the model is good enough, is above the threshold accuracy that we determined before. Remember, it was 0.70 by default. So if it's better than that, okay, I'm ready to generate baseline metrics for this model. So I'm gonna get into the condition step and do all of that. And then in the definition of the pipeline, the only thing that we're doing different from almost every session before is adding the data quality baseline step here. So we add the data quality baseline step here. I added the model quality baseline step here as part of the condition. We're good to go. We can execute this session 17. I did that offline. Let's take a look at it. Go to pipeline, session 17 pipeline. Here you have it. This is gonna have a few steps. So you'll see here, okay, so we have a pre-processed data step. All of that we know. We train the model, evaluate the model, check the model accuracy, create model. So after we put a stamp on this model saying, yes, the accuracy is above the threshold, well, I'm gonna create a model. And from here, I'm gonna generate the test predictions. This is the batch transform job behind the scenes. It's gonna run. Then we're gonna generate the model quality baseline. And finally, we're gonna register the model. Here are our two quality baselines running side by side, right? The data quality baseline and the model quality baseline. This model is going to contain a ton of new information. Why? Because we configured the metrics for this model to feed off those quality baselines. Let's go to the model registry and you'll see this is beautiful. If I go to the pipeline penguins and I open my latest version, notice how much more information I have under the performance tab. I have a confusion matrix that was automatically generated by SageMaker by using the baselines that I just created. So this is the confusion matrix. I have the accuracy. Remember that I told you it was gonna be 100% because there were no mistakes. So now I reported the accuracy, I reported the weighted recall, weighted precision, weighted F.5 score, weighted F1 score, weighted F2 score, right? We have the accuracy best constant classifier, we have a ton of stuff, right? We have a ton of metrics that now we enjoy because we ran the quality check step and we used those values to populate the performance information here in the model registry. Okay, so now let's see the output of that step. I have here in step number 9, I'm just checking the constraints that are gonna be generated by the model quality step. And as you can see, if you execute that line, it's just gonna print the contents of that file. It's just displaying what the accuracy is, the weighted recall, the weighted precision, the weighted F1 score. It's basically just displaying the information that we have that in the model registry. These two sessions, session 17, session 16, gave us everything that we need to start monitoring our model, because now we have a baseline of what the data should look like and a baseline of what the model performance should look like. So in the next session, we are going to start setting up monitoring jobs to ensure that our models are working the way they should be. I'll see you then.